Hello everyone. So in this video we'll see how we can use OpenCV in Scratch to do grayscale, edge detection, color filtering, segmentation and shape detection and other things. So let's just see a demo. So you can acquire the image using two ways, like from the camera or from the stage. Let me just acquire it from the stage. And this is like our normal Scratch sprite, like this is the bear and this is the jungle background, and this I just downloaded from the internet, some crosshair, and uploaded it into the project. So using this function you can capture the image from the stage, and then I can save the image also on the hard disk, and I can delete that image in memory. So whatever the image is captured, I can delete that image which is in the memory. On the save image, actually download the image into the hard disk. So let me just run this and see. So this is our downloaded image, which is same as the stage image. So the stage image is downloaded into this file, and you can see the coordinates here are width is 600 and the height is 450. So our coordinates in Scratch run from -240 to +240, -180 to +180, but the canvas size internally is different on each machine, and based on your machine, your machine resolution, the canvas size would be different, and similarly the image downloaded from the canvas will have a different resolution. Similarly, if you are using a camera, the image resolution would be different. So in my case, it's 480 by 360, so it depends upon your machine, camera resolution and other factors. So let me just do grayscale conversion and show you what is grayscale conversion. So basically it will convert into shades of gray. Now we'll blur this image. So let me just run this program and show you. So this is our blurred image. So you can see there is a difference in the sharpness between the stage and this blurred image. So you can apply grayscale, and then you can do edge detection also. So this is our edge detection on the grayscale image. Now the image can have various models, internal representation, it can be in RGB or it can be in HSV. So RGB is your red, green, blue, and HSV representation is your hue, saturation value. So colors can be represented in different forms, and similarly the image can use different forms to represent the colors of each pixel. So for filtering, we have to first convert it into HSV, then we can use the filter function. After using the filter function, you can again convert the image to RGB and save it. And the filter function will require two parameters. One is your lower threshold and second is upper threshold. And each threshold will have three values. So I had already done some experimentation, so based on that I know what values to use. So generally hue goes from 0 to 179 or 255, and saturation goes like from 0 to 255. Similarly, the value goes from 0 to 255. So I'm filtering all colors which have like hue below 64 or like hue above 179. And then I'm again like converting it into RGB, which is your PGR model, and then saving the image and deleting whatever the in-memory representation it has. So you can see like it has removed all the other colors, only kept this brown color. Now we can like apply grayscale and do edge detection on this image. So you can see like it has detected the edge of the bear. Now this is like for circle detection. We already have a video on YouTube regarding like circle detection. For example, if you have a robot and you want to chase a ball, you can use this hue circle using threshold, and you can give your threshold values and you can use X and Y position of the detected circle. Here we'll find the contours. So like after the edge, like we have to find the contours. So I'm not saving it, I'm just running it. Now I'll check like how many contours it has detected. So it has detected only one contour. So like our job has become easier. We can simply like go and like find the X and Y coordinate of that contour. But if you have a multiple contours detected, like I'll just show you like what is meant by that. So I'll draw that contour and show you. So this is our contour which is detected. If you have multiple contours, like each contour for each segment, you can like do average of all the X and Y. So you just add all the X values for each contour, and then you can like divide by the number of contours to get you an average value of the X and Y. Here like I'm just getting only one contour, but the concept is basically the same. So what you have to do is like I'll just show you. Let me just create two variable X and Y, and a counter variable also, and I'll set everything to like 0 0 0. Now I don't need the save image. So I'll run a loop like repeat number of contours, and I'll change the counter by 1. So I'm adding like x values of each counter into the x variable, and then like once it is done, like I'll take a median of those values. And because we are dividing it, so like it can be in floating point also. So currently like number of contours is one only, so it's okay. But let's say if the number of contours is like three, so your x can be in fraction. So like what we can do is like we can round it. Now this will give us x and y in the image, but our image is like 600 by 450. So we have to map it to our stage, which goes from minus 240 to plus 240, minus 180 to plus 180. So what we can do is we can use that Arduino extension, and where we can use this map function. And we have to map the x and y values, and the x goes from 0 to 600 in the image, and 0 to 450. So 0 to 600 is our width, and 0 to 450 is our height. And we have to map it our coordinate system. So it is like 480 width and like 360 height. And because like we have to map it again, like because 0 to 480 is the width, but our coordinate systems runs from like minus 240 to plus 240. So like I'm like reducing minus 240. So like if it is 480, it would become like 240, so it will become at this end. So if it is like 240 in the center, so like I'll minus it 240, so it will become 0. Similarly for y, I have to minus it from 180. So in the image, like y starts from here and goes like here, but in our image like it increases from down to upwards. So I'm actually subtracting it from 180 for that reason. Now we have our x and y coordinates, so I can just say go to, and before go to I have to like move it to front layer, so that the crosshair should not be like hidden behind the bear. So I'll add it at the top. And we have a sound also, gunshot sound also uploaded here. So like I'll just start that sound. Now I'll create another function, like when the space key is pressed, I'll reset the crosshair to some random position. So like go to some random position, and I don't need this counters to be visible. So this is our image and this is our counter, and I am getting its x and y position, and I'm moving my crosshair to that position. So currently the crosshair is here, so it should come here like somewhere. So let me just run and see. So this is the starting point of that contour. So based on that, like I can add like few more pixels to the right and few more to the down. Now let me press the space key. So it goes into some random position. Now let me just run it. Let me try like 50-50. Let me press spacebar. Now let me run it again. So I can try like 80. Run this. Now let me again run the program. So it will like go to exactly in the center and like hit that bear. So let me run it again and show you. So as you can see, like how easy it is using CodeSkool Scratch to do various image manipulation using OpenCV functions. So I hope you like this video. Please do like, share and subscribe. Thanks for watching.